Hi, I've got a bunch of stuff on my desk, and we all know what that means, don't we? It's project building time. Greetings, the Astro 30 here yet again with a semi-exciting project to build here. Now, JCar seriously need to start sponsoring me because I spend so much money in there, well I have lately. They need to sponsor me. So JCar, if you're watching, get on that please. Thank you very much. Anyhow, on to today's topic. I'm planning on building a x10 oscilloscope probe. I did actually make a video and build one a couple of weeks ago, which I haven't uploaded yet, and if you want me to upload that, I will say the results are not great. I will upload it, but put a comment down below and I will consider uploading it. The concoction that I came up with is so much more complicated than what I'm planning to do today. So anyway, I've been to JCar. I've got one of these, they're called IC clip leads, and it's catalog number HM3040. And the way that you work with these is you just gently squeeze where that little tab is, and it comes apart, so you can actually solder your wire to it. But for now I don't need that apart, so I'll put it back together. And that's how easy that is. I've got a 50 ohm coaxial cable here, which is about 1 meter long. I've got HM3020, which are red and black clip leads. All I need, or alligator clips, all I need is the black one. I don't need the red one, but I'll keep it for another project later. I got RR0660, which is 10 mega ohm, 1% half watt resistors. It'll become clear why I've got 10 ohm in just a moment. I've also got a solderless PP0652 BNC male connector, which is actually a screw terminal termination. So there'd be a small little gap in there maybe, or you just wrap the wire around it and then screw it up to make your connection. It looks like I just wrap the wire around it and then screw it down, and then you crimp along the cable and the shielding part to make the negative side connection or ground connection. So there's that, and I've got a beer sitting in the background over here that I'm drinking, and hopefully I can still do electronics whilst slightly inebriated, but we're going to try it. But first let's look at the schematic that I'm planning on building with this stuff. Okay, so let's have a look at the schematic of what we're doing. Here are our test leads at one end. One's just going to be a red IC type clip, and the other one's an alligator clip with the ground. See the ground there. This goes through a 5 mega ohm resistor and a 1.25 mega ohm resistor, which in series with this coax cable, 50 ohm to 75 ohm is fine. This forms a voltage divider, and then the coax cable then goes off to the scope, which has a rough input impedance of 1 mega ohm and 10 to 20 picofarad, roughly. And for each meter of 50 ohm coax, you're looking around about 100 picofarad of capacitance. This ends up being a fairly high impedance to the device on test, so it shouldn't really make that much difference to it. How accurate this is anyone's guess. I haven't built it yet. I'm going to, and we'll see what the results are. However, 1.25 mega ohm is a weird resistance which doesn't actually exist. So this would actually be two resistors in series, a 1 mega ohm and a 250k respectively. And I'll also put a link in the description to where I got the idea for this little project, and it goes through all the mathematics and the design process of actually building a probe inside a pen casing. A little bit bigger than this though. However, why does this end up being times 10 or 10 to 1? Well, its R2, which is the 1.25 mega ohm resistor, is in parallel with the input impedance of the scope. So our equation would be 1 divided by 1 divided by 1.25 plus 1 divided by 1.25, which equals roughly 0.5 reoccurring. Okay, so the ratio then would be 5, which is the 5 mega ohm resistor, plus 0.05 divided by 0.05 would equal 10, or a ratio of 10 to 1. Isn't that neat? Math is great. Yay. Alright, well, let's build the thing. And with this 1.25 mega ohm resistor, the guy that wrote the original article did say you can just use one resistor instead of having the 250k in series with the 1 meg. You can just simply use a 1 meg and it's close enough. But the proof is in the pudding. Let's find out. Right, so that's the schematic, and obviously it's using a 5 mega ohm resistor, and I can't buy 5 mega ohm resistors because JCar don't sell them. It's only 1 or 10. So I've got a pack of these, so I'm going to put 2 of these in parallel to make the said 5 mega ohms. And yeah, that should work just fine. So rather than talking about it, let's build it and see if it works. First I'm going to start by removing the insulation on the outside of the coaxial cable. So I've got this shielding copper here, which I'll twist together now. You also got this extra shielding aluminium foil, which I can't solder to, so that's going to have to go. So that can go and bugger off over that way somewhere. So I will take some cutting apparatus and I'll just cut this foil off because it's not needed. Okay, and I can solder my 1 mega ohm resistor to the ground and this after I strip it. So I'm just going to strip the end of this. So I can take my 1 mega ohm resistor and I will wrap up close to the center lead, the lead and the negative or ground shield wiring around the leg of the resistor, like so. I'll put him down on the desk, and it might help if I actually had some solder handy, which I don't. Alright, so I've got some solder handy now. I will solder the resistor to the ground, like so. Now for now I'm going to leave that leg on there. I'll sort that out shortly. Then I'll take the other end of the 1 mega ohm resistor and I'll wrap it around my center lead, like so, and then I can cut the excess off. I'll solder that. Like so. Brilliante. The cutters that is now conveniently holding everything together. Just trim that end of the lead off. Now I need to make 5 mega ohm, so I'll take 2 10 mega ohm resistors out of the packet. 1, 2, and I will twist the leads of each resistor together so they are one on both ends, like so. Now that's what it's going to look like. It's not perfectly neat, but it'll do the job. So I can now basically tin them together towards the ends. Like so. And I will measure that with a multimeter in a minute, just to see what... that's hot. No shit, Sherlock. What the actual ohmage is. So I'll just trim off the excess leads that I don't need here. Okay, beautiful. Time to measure. We've got close to 5 mega ohms. It's 4.96, which is pretty much close enough. So we bring this back in. I now need to solder my two resistors here to the center lead here. I might turn it around a bit so I've got better access it from this side. Okay. Now I'm just going to hold these resistors and burn myself in the process, but that is probably not the best solder joint in the world, but it is indeed a solder joint. So this sort of completes this end. All I need now is to put a positive lead on here and my ground lead on here. So my hand may be in the way. But that's unavoidable. Yeah. There's my ground lead, so I might touch that up with a little bit more solder. Hopefully the lead doesn't come flying back off again. No, I'm good. I will actually pass my untinned wire up through the resistors and hook it over so it's actually hooked onto it. And now I will solder and tin it at the same time. There we go, not too much, otherwise it'll melt it. And there we go, we're getting something that resembles a probe. Alright, so I've got a bit of heat shrink here. I don't know if I can get that all the way over the resistors. I can try without bending the fuck out of them. Add a bit of spritz there and see if I can make this slip over a little easier. If not, I'll leave it. That's fine, I'll leave it. So just heat shrink that down. That'll just protect my solder joint there at the end as best as possible. Sweet. Now, what I might do, let's grab the pliers, put that there. I might cut a little bit of a relief here in the end, just to make it that much easier to get out of the cable, because this is slightly too small. Should be fine. I didn't think about getting any heat shrink. Probably should have. Alright, that's pretty much well done. I'll protect my resistor concoction there. Alright, now if I measure across both positive and negative leads, I should see that 1 mega ohm resistor. Well, actually no, I should see 6 mega ohm because it's in series with the 5 mega ohms. No, actually I'm seeing 4.43 mega ohm. So, okay. So I know those resistors are now still working. When I strip the other end of the cable, I will double check the resistance. Ah, you bastard. Pen came apart. Right, there we go there. There's the negative end done. Now it's starting to look like a test lead. Now all I've got to do is to be and set the other end. With this, little bit of gap here, I might just wrap a bit of insulation tape around it or something just to cover it, like so. Now, just make sure that everything, like the shielding part of the cable, stays and behaves where it's supposed to. So I believe all I've got to do is put a little hook in this hot lead, hook it around the screw, something like that, and then I do the screw up. So I'll just do the screw up now. Something like that, and then we just tilt and bend, after probably opening that crimp just a tad so we've got more space, like so, and we make sure that we've got plenty of the copper wire touching the crimp. I can close the crimp. Like so. And I think that's pretty much done, but what I need to do is I need to test to make sure that I've got, well, resistance from the center back to the other side. So I'll take positive lead and I'll just gently clip that on there. And I'll take my negative lead and I'll touch the center. Like this, and we now have 3.6, something like that, megaohm. So I know that that is continuous. I will just check the ground. We've got 0 ohms, so that is connected electrically, so that's good. So I'll just make sure that these aren't going to short by taking my screwdriver and ramping it up a bit. And then I can find wherever that went. And actually screw the assembly together. I believe it screws, or does it just push on? No, I think it just pushes on. Yeah, it just pushes on. There we go. All done and dusted. So we've now got a test lead, which I have no idea whether or not it works. Okay, I've got everything set up on the desk now. I've got my oscilloscope. I'm currently in my normal ×1 probe going into my signal generator. The frequency is not that real important, but I will put it back up to close to 1 kilohertz. Anyway, all I'm interested in is the voltage peak to peak output at the moment, which is 4.45 volts ×1. So I'll disconnect this probe now. I'll grab my new concoction that I have just built, move it around a bit so I can actually connect it up. Like so. Don't have any weird noise on the scope, which is good. I'll disconnect that probe and I'll connect up this probe now. Somehow. There we go. We've got a small signal and it says it's 0.62 volts, so it's not quite right. So there is a function to change the oscilloscope reading from ×1 to times 10. Now he reckons it's putting out 6.2 volt rather than 4.45, so there is still a discrepancy. So yeah, it doesn't quite function as it should. Okay, so that didn't work out so crash hot. That was highly inaccurate. It's at least 1.5 volts out from memory. I'm doing this on a different day. I'm going to do what I should have done in the first place, and that is breadboard the bloody thing out. Now, the circuit originally called for a 1.25 mega ohm resistor, which is basically a 250 kilo ohm resistor in series with a 1 mega ohm resistor to make the 1.25. I've got a variable resistor here of 1 meg because, well, I couldn't get a 500k, and I'm going to adjust my pot until I get 250. This is a 25 turn pot, so getting there. Not quite. Still off. That's about as close as I'm going to get it, I reckon. And I have a coffee with milk today. Yay. Now this is assuming, of course, that the scope has a 1 mega ohm input impedance, which means it should have a 1 mega ohm resistor across the input. And according to the meter, it's more like 24, but I think I'm in DC. I'm in DC to be in AC. It's still more like 24 mega ohm DC resistance. So I've got my oscilloscope set up and my little oscillator here off to the left. So all I've got to do now is connect the correct wire to the input of the times 10, so-called times 10 probe. And well, we have 0.52 volt now, which is interesting. According to that, we've got roughly 0.46 to 0.56 input there, or output I should say. What was I doing? I've completely forgot what I was doing. I was going to verify what the actual input voltage is. 4.45, okay. And now 0.45, so I'll increase amplitude so we can see it. Now let's see what happens when I adjust the trimmer. Going up in resistance, not much is happening. Going down in resistance, again not much is happening. Except that it's moving around all over the place. I've come to the stop of the resistor too. So adding that trim pot really didn't achieve anything. So I'm going to move on to my next test. So I've swapped out the variable resistor now for a fixed 240 kilo ohm resistor, which is about right. And we've still got around about, I'm going to say 0.5 of a volt there, which is close enough I suppose. But if I change that to times 10, you can see it's jumping around between 4.6 and 5 odd volts, so that's probably as close as times 10 I'm going to get. How will this work on the cable? Well, there's only one way to find out really. So I've swapped it over now for the homemade probe, which is much more stable, and wouldn't you know it, the voltage is actually correct. However, I do still have this test thing hooked up and it's actually going across a bunch of resistors. So I'll remove the lead, still 4.6, and just for reference I'll lift the ground. Still 4.6. Isn't that something? That is odd, because the other day when I tested it, it wasn't 4.6, but now it is. This is a complete mystery to me. I'm slightly perplexed now because it wasn't functioning correctly the other day when I made it, but it is now, which is strange, but okay. And just for shits and giggles, I've actually connected the multimeter across the output of the oscillator where the probe is connected, just to measure what its voltage coming out is. In voltage AC it only shows me 1.2 volt, but in volts DC it's showing me roughly what the oscilloscope is showing, which is 4.49 versus 4.5 to 4.6, so it's probably about 100 millivolt out, which is not bad. So I want to say it is close enough, but yeah, I've got no explanation for you. It seems to be functioning as it should. How accurate it is, you know, probably about 10% inaccurate, but it does what it does, and it gives you a quick power. Can give you a quick power measurement on power amps and stuff like that for a times 10 probe. Real 10 times probes have a fair few other passive components in there for compensation, as well as capacitance adjustment, so that they can get it as accurate within 1%. But anyway, if you enjoyed this video, please remember to rate, comment and subscribe below, and you can always follow me on Facebook and become a Patreon member for as little as $1 a month. I'd like some more Patreons, please. Anyway, this is the Astro 30 saying I'm perplexed, but it's working, so okay. Have a great day.